Woo. Woo. Hello, everybody. Can you hear me? Did you see me fix my hair? I'm afraid I got caught in my own little John Edwards moment there. Welcome to lesson number 7. We're going to do Quant 7 and Verbal 7 today. I'm going to try not to use the camera as my own personal mirror, even though I do see myself, and I'm still irritated that I have some frizzy hair. But you know what? We go forward, we do what we can, and we focus on the content. Yeah, thanks, Andrea. Appreciate it. I'm not going to say what Andrea said, but it was a comment about my hair. You know what? This is what I think. First of all, the important thing is my GRE score. Secondly, the second most important thing is that I have hair. And I'm in my 30s and I have hair, and that is what matters. I'm keeping it as long as I can. That's it. Okay, so let's move. Let's do it. Okay, touche. I'm glad you said touche and not toupee. Oh, I've been too close to an insult. Okay, so first things first. There are only 4 of you here, so this is a very small private class. So go ahead and ask me questions. Ask me anything. AMA right now. Okay, welcome. Someone else just got here. Hello, Andrea, Crystal, Jen, Silvani, and Whitney. You all have been very good about emailing me. But go ahead and ask any questions, GRE related, studying related. What do you got? Anything at all? I'm going to open, close some of this stuff. Any questions? Any questions whatsoever? Aha, we have a question. Question is, can we get some tips for the writing portion? Yes, you may. I will. Yes, I know. I have shut off the screen so that I could open the magic files. So, all right. Tips on the writing section. Okay, so Vani, the writing section is a very simple, formulaic part of the test, and we will cover the writing section the last class. So I think our last class is Thursday, if I'm correct. Julie, is that correct? Are we coming up on the last week? I can't believe I have to say goodbye to you already. It's really very upsetting, actually. But the good news, you all have my personal email, and I know you all will be in touch, because as the class has gone on, I have heard from you, some people, much more frequently. I like it. I do want to say that I'm quite responsive right now, and I will be responsive through this week. After this week, less responsive, because I will have other classes. So please, if you have questions, if you have things that I can answer about your GRE, now is the time to be studying. I assume you've been studying, but now is the time to really be studying. And ask your questions. Ask your questions ahora mismo, right now. Do not delay. I will be less responsive after the class. As far as the writing, yeah, we will cover the writing on Thursday. Okay. Other questions? Other questions? So, Vani, if you could bring that up. I'm 98% positive that is in the lesson plan, but if we get to the middle of the lesson on Thursday and we haven't covered it, I will stop everything and I will teach you the writing, because the writing takes about 25 minutes to teach. It's not that hard. Okay, other questions? Anything else? Okay, we're going to finish Quant 6, and then we're going to dive into Quant 7 and then do Verbal 7. Here we go. All right, I think we left off. And diagrams, good. I think we left off here. Is that right? Did we do this question? I think we did this question. Did we do it? Did we do this one? Example 7. I've definitely done this question in the last 2 days, so hopefully I've done it with you. Verdict is yes, we did it. Okay, super. Okay. The formula for probability. Here's how probability works. Probability is the number of desired outcomes over the number of possible outcomes. So what's the probability that you roll a 1 when you roll a die? How many desired outcomes are there? How many possible outcomes are there? Go ahead and type it in your text box. We're a small little class today, so lots of interaction. Yeah, so Andrew, what's the probability? Yeah, 1/6. Whitney got it. Okay, 1 desired outcome over 6 possible outcomes. How about the probability of rolling a 3 out of 6? Or the probability of rolling a 3. Rolling a 3, what's the probability that you roll just a 3? Yes, still 1 out of 6. That's right. What's the probability that you roll a number that is higher than 4? What's that probability? How many desired outcomes over how many possible outcomes? Yeah, 1/3, which is 2 out of 6. So 5 or 6, you can roll 5 or 6 out of 6 total possible numbers. Good. Okay, let's move on. Probability of an event not happening is 1 minus the probability of that the event does happen. So what's the probability of not rolling a 4? What's the probability of not rolling exactly a 4? What's that probability? It's a different question that's on the slide. What's the probability of not rolling exactly a 4? 5 out of 6. So Andrea, what's the probability of rolling exactly a 4? It's 1 out of 6. So 1 minus 1 out of 6 is 5 out of 6. Jin, you got it. Thank you, Jin. Okay, so what's the probability of not rolling above a 4 on a die? So what's the probability of rolling above a 4? Well, it's 1 minus that. It's 1 minus the probability of rolling above a 4. What do you got? No, Jin, that's not right. Oh yeah, Jin got it. I'm sorry, Jin, you are completely right. It is 4 out of 6, which is 2/3. That's right. Jin nailed it. Silvani nailed it. Whitney nailed it. You all got it. You're geniuses. Geniuses at probability. Well done. Okay, independent events, definition of probability. The probability of something happening and something else happening is you multiply them. So the probability of flipping heads and getting a 1 out of 6 on a roll of the die is 50% times 1 out of 6. So 1/2 times 1 out of 6, which is 1/12. The probability of something or something else happening. So what's the probability that the Redskins win the Super Bowl or the Rams win the Super Bowl if all the teams have an equal chance? Well, the Redskins are 1 out of the 30 teams, and the Rams are another 1 out of the 30 teams, so your odds are 1 out of 30 plus 1 out of 30, 2 out of 30, or 1 out of 15, okay? So or means add, and means multiply. Okay. This is dependent probability. So what are the chances of drawing 2 aces in a row from a deck of cards? Well, what are the odds you draw an ace the first time? So how many, there are 4 aces out of 52 cards. So what are the odds you draw an ace out of that first deck? 4 aces out of 52 cards. What are the odds you draw an ace? 4 out of 52. So Lonnie got it. 1 out of 13. That's exactly right. Now, what are the odds you draw an ace on the second card, given that you've already drawn an ace? What are the odds you draw another ace? Silvani nailed it. Anyone else? Whitney nailed it. Andrea, how many cards are left? How many cards are left in the deck? Jin, how many cards are left in the deck? You already have an ace in your hand. How many cards are left in the deck? Yeah, 51 cards are left in the deck. So your odds of drawing that first ace are 4 out of 52. Your odds of drawing that second ace are 3, because there are 3 aces left, out of 51, because there are only 51 cards remaining. So 3 out of 51. That's dependent probability. It's when the denominator in that second draw changes. So your first draw, you had 52 cards to choose from. The second draw, you have 1 fewer things to choose from. Okay? Cool. All right. Mutually exclusive events. So if things cannot occur at the same time, you can get a heads or a tails. You flip a coin, what are the odds you get either a heads or a tails? 1/2 plus 1/2. You're definitely, it's going to happen. It's 1. So you add them if you see the word or. You add when you see or, you multiply when you see and. Overlapping events. Okay. When 2 events could occur at the same time, then the probability of getting one or the other is the probability of one plus the probability of the other minus the probability of both. It's actually a good rule of thumb anyway. So the probability of one plus the probability of the other minus the probability of both. So what are the odds that the Rams win the Super Bowl or the Redskins win the Super Bowl? Well, probability that it's 1 out of 30 plus 1 out of 30 minus, what's the probability they both win the Super Bowl? Nothing. Okay? What about the Rams win the Super Bowl or the Red Sox win the World Series? 1 out of 30 plus 1 out of 30 minus the probability that they both win it. 1 out of 30 times 1 out of 30. Got it? Does that make sense? Does it? But does it? Does it really though? Doesn't. Doesn't. Yes? I'm not going to move on until someone says yes or huh? Yes or huh? Anybody? Yes. Good. Okay. Got probability. You are geniuses at probability. Let's see if you can do this question. I'm going to give you, I'll give you a full 2 minutes. Check it out. Go. Okay, coming back. Let's open the poll and see how you did in 3, 2, 1, and go for it. Oh, all right, guys. Gave you a little extra time in the hopes that we'd get 100% correct, and it wasn't close. Okay, 2, 2, and 1. 2 of you are correct. Let's load up the pen. I think we're going to do a green color today. Feeling a little green. College class consists of 24 CS, 16 marketing, and 20 finance. How many people in the class? That's the first thing you should do. Okay? 24 plus 16 plus 20. Okay, 2 different students are going to be selected at random. What's the probability that both will be marketing majors? Okay, so what are the odds that the first person is a marketing major? I bet you guys can get it. What are the odds that the first person? Well, how many people do we have? We got 60 here. And how many are marketing majors? 16. Okay. So if you did not get that far, you're in deep doo-doo. The probability is always the number of desired over number of possible. Okay, so number desired, 16 marketing majors over 60. Okay, so now both have to be marketing majors. How many are left? How many students are left? 59. And how many marketing majors are left? How many marketing majors are left? Whitney, you nailed it yet again. 15 marketing majors. And are we choosing a marketing major and another marketing major? Or are we choosing a marketing major or another marketing major? Which one? Andrea, we will unmute you. I will unmute you tomorrow during office hours. I wish I could hear you, Andrea says. Andrea is yelling at her screen like Tom Hanks in Castaway right now, which that's a very old movie now. Have you seen Castaway? You guys know what Castaway is? Tom Hanks, he like befriends a volleyball. Yeah? No? Okay. Anyway, so Andrea, I sympathize with you, but come to office hours tomorrow. I can hear your voice. We'll hear your voice then. Okay, so there are 15 marketing majors after we've already picked one. You want to pick a marketing major and another marketing major. Okay, so 16/60ths divided by 15/59ths, that looks like a nightmare until you realize that 15 goes into 60 exactly 4 times, so that becomes 4, and this is 1. And 16 over 4 is just 4 over 1. So you multiply across, 4 times 1 is 4, 1 times 59 is 59, and the answer is B. And that's it. Any questions to the 3 of you who missed it? Thank you, Julie. Julie is my comedy accomplice. She will be here all night, folks, all night. Okay. All right, any questions on this? Thank you, Julie. She'll be coming around for your drink orders shortly. Please, there is a 2-drink minimum on the GRE. That's not true. Don't do that. That's not true. Don't drink. Don't drink and test. Bad. Okay, here we go. All right, let's try this one. I will give you 2 minutes on this. Do the best you can. Go. Okay, folks, let's open the poll and see how you did. In 3, 2, 1. Go for it. Okay, we had 3 of you choose A and 2 of you choose C. All right, still seeking consensus here. Let's go back to the green pen. A bag has 2 green balls. Nice. 2 green balls, 3 blue, and 4 red. Cool. How many total? It's like 9 to me. Oh, 6 yellow balls. Oh, snap. It's like 15 total balls. Cool. All right. 2 balls are selected at random. Nice to know. The probability of selecting a green ball and a yellow ball. Well, if you select a green ball, what are the odds of that? 2 out of 15, right? All right, now you got to select the yellow ball. What are the odds of selecting a yellow ball? Well, there are 6 yellow balls. How many balls left in the bag? There are 14 left in the bag. You cannot select balls at the exact same time and get them out of 15. You have to go bloop, 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 bloop. That's what simultaneously selecting the balls means. You have to do first one, bloop, is out of 15, and then bloop, out of 14. Can't do it at the same time. It's like bloop, bloop. 2 out of 15 times 6 out of 14. Green ball and a yellow ball. Okay, so let's reduce here. You get 2, that's going to be 7. And this is going to be, what, 6 out of 15. That seems like 2 out of 5. So 2 out of 35. Seems unlikely. You can also select a yellow ball and then a green ball. Right? And that's going to be also 2 out of 35. Good to know. The probability of selecting a blue ball and a red ball. Blue ball, 3 out of 15 times 4 out of 14. Cool. So that's 1/5. And this is 2/7. Aha! 2 out of 35. Interesting. Or you could select a red ball and a blue ball. It's going to give you the same thing. Yep. So whether you got 2 out of 35 or 4 out of 35, which is the actual probability of selecting a green ball and yellow ball, assuming you don't care about the order, they're the same. So the answer is C. Questions? Any questions on that? Any questions? So I glossed over a little point at the end, which is that the probability of selecting a green ball and then a yellow ball is 2 out of 35, but the probability of selecting a green ball and a yellow ball in whatever order is 2 out of 35 plus 2 out of 35. Because you could have green-yellow, or you could have yellow-green. You could have red-blue, or you could have blue-red. Got it? So they are equal. Good job to the 2 of you who got that right. All right, let's move along. Okay, fundamental counting principle. This is fun. Most of you think you already know how to count, but no, you don't. You do, but it's different. Okay, so Andrew says, is there a time that the total doesn't change with each trial? Yes, there is during the fundamental counting principle. Also, here's a question. So if you had you have to make a code of 3 digits, and you can choose 10 digits for any. You can choose any digit for any number. So you can repeat basically. How many digits can you put in that first blank? Andrea, how many digits can you put in that first blank? How many choices do you have to put in that first blank? 10. That's it. Jin got it. Jin has stolen Andrea's thunder. Andrea, you can beat up Jin later. Not really, because you are separated by an ocean of distance and civility. So no violence. 10. How about that second blank? How many numbers do you have to choose from for the second blank? You can choose any number. So think about it. Andrea, take another guess. No change. So I'm making a code, passcode of 3 digits on a number pad. Okay? So I have 10 digits can go in the first spot. I have 10 digits can go in the second spot. How many in the third spot? Silvani, you are wrong. Wrong. Now you are right. Silvani is right. Okay. Andrea, yes. Good. So you can have 10 in every spot. 10 times 10 times 10, 1,000. 1,000 different passcodes. All right? So that's when the number doesn't change. Here's another way you can change. I'm picking, there are 10 red and 10 blue in a bag. What are the odds I pick 2 reds in a row with replacement? With replacement. All right, so here are my 2 slots. The first slot, what are the odds I pick a red ball? Take a guess. What do you think, guys? Whitney, you nailed it. Whitney destroyed it. It's 10 out of 20. Okay, now I just said there's with replacement. With replacement. So how many reds are in there now, and how many total balls are in there? If it's with replacement. You got it. 10 reds and 20 total. So it's still 1/2 times 1/2. The odds of getting 2 reds in a row are 1/4. 1/2 times 1/2. Got it? All right. So now let's do this thing on the slide right here. A certain car comes in 9 different colors, 2 different engine sizes, and 3 different trims. Engine color. Sorry, engine color. Color. Size, trim. What is the total number of distinct cars that could be ordered? So how many colors? Are there clue words to show? Andrea says, are there clue words to know when to change the total and when not to? Yes. Usually you will change the total unless it says with replacement. Or if it says you can choose any number at any time. It says something like that. So those are the clue words. Okay, so back to this. How many colors are there? Yes. 9 different colors. There are 2 different sizes and 3 different trims. And you have to have a color, a size, and a trim. So color and a size and a trim. 9 times a 2 times a 3, and that is 9 times 6, which is 54. Boom, 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 boom. Very well done. Okie dokie. Erase. And let's move along. Oops. All right. Factorials. Factorial is multiplying the number times every integer below it. So every positive integer below it. So 5 factorial is 5 times 4 times 3 times 2 times 1. That's it. Fun fact, 0 factorial equals 1. They do that so that certain equations will work. But everything else is pretty self-explanatory. So 8 factorial divided by 6 factorial, here is how you write it so that you don't go crazy. 8 times 7 times 6 factorial, all divided by 6 factorial, okay? You don't need to write anything else, because guess what? 6 factorials cancel. That's it, okay? Fun fact, when you are putting X things in a row with X slots, there are X factorial ways to do it. What does that mean? Well, if I have 5 kids and I want to arrange them in 5 seats, how many ways can you do it? Well, how many different kids could you put in that first seat? Take a guess. Different kids could you put in that first seat? 5. You got it. How many different kids? One person is in a seat. How many different kids could you put in that next seat? Yeah, 4. You got it. How about the next seat? Yep, you got it. 3, and then 2, and then 1. You got a person in the first seat, and a person in the second seat, and a person in the third seat. That is 5 factorial. 5 times 4 times 3 times 2 times 1. Cool. Okay, there's a formula. This is the permutation formula. Formula. N factorial divided by n minus k factorial. What the hell is n factorial? That is the, n is the number of folks in the pool. So, for instance, this is your n. K equals number of slots you need to fill. Okay? N is the number of folks in the pool. In the pool. K is the number of slots you need to fill. So in this case, we have 5 factorial over 5 minus 5 factorial. 5 factorial over 0 factorial, which is 1, is just 5 factorial. Any questions? What is the equation? It is hard to read. Okay, here I'm going to erase everything. I'm going to write it in plain black. Okay. N factorial divided by n. Okay? That's the permutation formula. Is that better? N is number in the pool. K equals number of slots. Cool? Good, good. All right. Any questions? You have that written down. Can I move on? Blink twice if I can move on. Write it in. Okay, can't actually. Okay, let's go. Okay, combinations and permutations are both methods of counting the number of ways objects can be arranged or selected from a larger set. Permutation. Order matters. ABC is different from CBA. Combination. Order does not matter. ABC and CBA are the same things. They're on the same team. It's the same team. So, for instance, if you get selected for a team, like the U.S. gymnastics team, do you care if you are selected third or fourth for the gymnastics team? Everyone's on the same team. Or like, are you selected third or eighth for the U.S. soccer team? I don't even know how they do that. But if you're running a race, do you care if you get third or eighth place? Yeah, you do. So if you switch up the order, does that mess things up? That's how you determine whether or not order is relevant. Here are your formulae. So there is the formula I just wrote. Combination formula, exact same thing, except you have an extra k factorial in the denominator. So you put an extra thing in the denominator, does that reduce the number of total options or increase the number of total options? Write it in your text box. Put something extra in the denominator. Does that reduce your options or increase your options? Decrease. Jin has nailed it. Crystal, come on. If I have 1/2 and then you put an extra 8 in the denominator and change that into 1/16, do you have something more or less? Yeah, less. Although, Crystal, when I'm splitting pizza, I am definitely going to do it with you from now on. Just kidding. Don't confuse it. If you're confused by the letters, put some real numbers on it. So 1/2, and then you put an 8 in the denominator. Oh my God, that got so much smaller. It got so much smaller. Okay, good. All right. Okay. Let's skip this. All right, go ahead and try this one. This one is fun. I'll give you a 1.5. Go. Okay, coming back. I'm going to open the poll. In 3, 2, 1, go for it. Okay. 60% of you think it is D. Let's see how you did. Okay, applicants to a certain college are identified using a code consisting of 2 digits followed by a letter. Or of 3 digits followed by a letter. Each digit is selected from the digits 0 through 9 inclusive, and each letter is selected from the 26 letters of the alphabet. If the digits may be repeated, and if the same digits used in a different order represent a different code, how many different applicants can be identified with these codes? Okay. We have 2,600, and we have 26,000. 26,000 plus 2,600. 28,600. Good job for those of you who got D. That's it. If you are confused, tell me why in the text box. In the text box. So 2 of you missed it, but you completely understand it now. Totally understand it. You'll never miss this again. Is that right? Okay. Crystal used the permutation formula. Okay. Why will the permutation formula not work in this case? Anyone? When do you use the formulas? You use the formulas when, in many scenarios, but they have to make sense. So it's when you're selecting a number of people from a pool, when you're selecting a number of objects from a set of possible objects. So in this case, we're making a code. We're coding folks, and there are things that can be repeated, and the same digits can be used in a different order, represent a different code. So well, that part is permutation, very permutation-y. But there are several hints that this is not a permutation. Number one, you're mixing letters and numbers, so you're mixing two different kinds of things. So that's not good. That's not good for the permutation formula. And secondly, you can repeat things. So in permutations, can the same guy get both first and second place? I mean, if he's Usain Bolt, he can get whatever he wants, but that's not actually possible. So you cannot repeat things. One digit or one person cannot take up 2 slots when you're doing the formula. And if that's true, if one person can take up 2 slots, the formula is not appropriate for that problem. What about putting things in order? Well, what about putting things in order? So, does order matter here? Yes, order matters because a different order is a different code. So that's what I said. That is consistent with thinking that this is a permutation. However, it's not a permutation because you can't, because you could have a code that goes 0, 0, 0. A. 0, 0, 0, A is a code. And that won't work in a permutation. Once you have used up a thing in a permutation, you cannot use it again. So if you think about the one thing we did earlier, 5 people in 5 slots, your classic factorial, classic permutation. Can you have 5, 5, 5, 5, 5? Is that a thing? Not a thing. That is something, if you have, that's code making. It's not a permutation. It's not 5 people in 5 slots. Okay. It is a permutation when you are selecting a few, when you are making a selection of people or things from a set of possible candidates, and you are only allowed to select each candidate once. That is a really messy definition, but that's true. You'll get the hang of it as you do more and more of these. Andrea, if you have any trouble with permutations, come to office hours and we will talk about it more because I love permutations. permutations, some of the most clear and beautiful questions on the GRE, in my opinion. Yeah, I said it. Beautiful. That's what I said. Okay. All right. Let's erase this. And let's move on. Okay. This is tough. I'm going to do this one for you. 9 keys on a keychain, of which 5 are for exterior locks. Oh my god, I've missed this twice. Oh no. 5 are for exterior locks and 4 are for interior locks, okay? How many possible selections of 5 keys from the keychain contain at least 1 key for an exterior lock and at least 1 key for an interior lock? Wow. So possible selections of 5 keys from the keychain contain at least 1 for an exterior lock and at least 1 for an interior lock. Okay. Well, whenever you're doing this, you can count up all the possibles. Or you can subtract impossible from the total. So how many ways could you get a selection of 5 keys from 9 keys? Well, 9p5. That's 9 factorial divided by 4 factorial. So that's a huge number. 9 times 8 times 7 times 6 times 5 times 4 factorial divided by 4 factorial. Wow, that's huge. Okay, so that minus, oh, wait a minute. That's not it. Because you can have, is it a combination or is it a permutation? What if you select like A key and then B key? Is that the same as selecting B key and then A key? In this case, yeah, they're all just going to be on the same keychain. All right, so it's 9 factorial divided by 5 factorial. 4 factorial. Cool. That's better. So 5 factorial is 5 times 4 times 3 times 2 times 1. Great. Boom, boom. There's 8. This is 2. So now we have 9 times 7, which is 63 times 2, which is 126. Is that right? 63, 126. Great. Okay, so 126, that's without restrictions. And then how many ways can I break it? Well, how many ways can I do a set of 5 and not have at least 1 exterior and at least 1 interior? Well, I could choose all interior locks, and I'm still going to get at least 1 exterior lock. The only way to do it is if I get all exterior locks. And there's only one way to select all exterior locks. You got to run the table. You have to select them all. So that is your answer. Tough, but I just did total minus the impossible. I did total 126 ways that I can choose 5 keys. 9 choose 5. So 126 ways I can choose 5 keys out of a set of 9. But I can't choose all exterior locks. I can't do that. And there's one way to choose all exterior locks. 1 team of all 5 exterior locks. How did 6 become 2 in the numerator? Aha, let me do that a little more slowly. Okay. So we had 9 choose 5. So we have 9 factorial divided by 5 factorial, 4 factorial. Or no, yeah, sorry, 9 factorial divided by 5 factorial, 9 minus 5 factorial. So we end up with 9 times 8 times 7 times 6 times 5 factorial divided by 5 factorial, 4 factorial. So there goes that, and now I have 9 times 8 times 7 times 6 divided by 4 times 3 times 2. And I crossed off 4 and 2 and crossed off the 8. And then I crossed off the 3, and then I made 6 a 2. Okay, so 9 times 7 is 63. 63 times 2 is 126. That's how I got it. Cool? Why did I stop at 5? Well, Andrea, check this out. I could write 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But now my hand hurts, and I'm having cramping right now. And then on the bottom, I have to write 4 factorial and 5 times 4 times 3 times 2 times 1. And my hand's cramping again. And all I did is I just wrote this out twice. That seems unwise when I could have just written what I wrote here. Okay, so I always stop at the largest factorial. So I only have to write down to that factorial, and then I just cross them off. I right justify that largest number factorial. I right justify it here, and then I cross it off because it's on the top and on the bottom. Does that make sense? Andrea? Andrea, this is all for you. Okay, good. All right, cool. Any other questions? Please ask the questions. There are only 5 of us in here, so intimate session, ask away. Are you good? All right. Cool, cool. All right, we are done with probability, my friends. In-class practice, examples 12 and 13, please do on your own, but those are good ones. That one's especially good, example 13, and there's your homework. Homework data analysis, that's 1 to 3, which you did, I think, and sets and probability, and data analysis, sets and probability. So these 2 right here. Those are your homework for next time, okay? So do that. Now we're going to jump to the PowerPoint version. Let's check this out. PowerPoint version, of Quant 7. Cool. So can you all see this? I'm going to do it on PowerPoint because that's the file I was sent. Okay? Can you see it? Let's see if we can. Is that too big? Can you all see that? Yes? No? Oh. I can go back and forth here. Can you see it? Yes? I'm getting no response. Okay, great. All right, so let's do this. Quant. All right, there you go. Geometry. Jesus. Okay, we're going to do geometry, angles, geometric notation, triangles, different right triangles, and equilateral triangles. Let's do it. Okay, we're going to create angles. We're going to study vertical and supplementary angles. We're going to explore the properties of interior angles. We are going to talk about Victoria's Secret angles. We're going to talk about angles and demons, all sorts of angles. Identify the variety of geometric notation, become familiar with various polygons, etc., etc. Okay, here are the basics. Geometry is all about angles. Many geometry problems on the GRE involve angles, which are measured in degrees. So an angle is the space that's formed between 2 rays, which intersect at a point called the vertex. Yawn. You know what an angle is. An angle looks like that. It looks like M. It's like M. So this is an angle. Since rays are considered a portion of a line, angles are also formed when lines intersect. Cool. There's an angle. On the right, angle M is formed as two rays in blue diverge from the vertex. That's your vertex right here, and here are your rays diverging. Good? Okay, geometric notation. You will need to be able to recognize geometric notation for points, lines, angles, and geometric shapes in the geometry. Here are some basics. All right. AB looks like this. AB is a line segment whose endpoints are A and B. AB is a ray that's starting at point A and extending infinitely in the direction of B. So this is AB ray. AB is parallel to CD, means lines AB and CD are parallel. AB is perpendicular to CD, means they are perpendicular. Okay? Angle ABC is the angle formed by the rays AB and AC. So this is B, and this is C, and this is A, an angle. That's wrong. This is wrong. So this should say angle BAC is the angle formed by rays AB and AC. Okay, BAC, because the middle letter is the letter that gets the angle. The middle letter is the letter that gets the angle. I repeat that. The middle letter is the letter that gets the angle. ABC is the triangle with vertices A, B, and C. Cool. In geometry, the length of line segments is measured by units, and the size of angles is measured by degrees. Some important degree measurements to know: a right angle is 90 degrees. 3 angles in any triangle add up to 180. A straight line contains 180 on each side. A circle contains 360. The 4 angles of any quadrilateral add up to 360 degrees. So if you have this, the 4 angles are 360. If you have this, it's a triangle roughly. So bad. These angles are 180. Okay? Great. Any questions on this page? It's a very, 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 very important page. Any questions? Okay. All right, vertical angles. When lines intersect, their point of intersection forms the vertex for the resulting angles. What the heck does that mean? It just means that when 2 lines intersect, 2 of the angles are the same, W and Z, and the other 2 angles are also the same, but in different ways. So this, let's say this is 120. Well, then what is X? Because this is a straight line. So what's W plus X? W plus X has to be the straight line, has to be 180. So what's X? Write in what is X? Yep, Crystal, you nailed it. Crushed it. So what's Z? If this is a straight line, what's Z? Yep, you got it. Crystal is in fuego tonight, guys. This is 60. In fuego, that's it. So W and Z are called vertical angles. X and Y are also vertical angles. All right? So that's it. That's vertical angles. Nice. Okay. Supplementary angles, sum of the measures is 180. So W plus X, those angles are supplementary. Cool? That's it. W and Y are supplementary. Y and Z are supplementary. X and Z are supplementary. So they're all on straight lines. Interior angles. Okay, when a pair of parallel lines is intersected by a third line, okay, so they have to tell you that this line here is parallel to this line here. I have to tell you that. That is crucial. So if they are parallel, then you can tell all sorts of things about these angles. Two sets of 4 equal angles are formed. So A and D are the same, but then D and H are the same. And E and A are the same. Because this right here, this intersection here is exactly the same as this intersection here. It's just mirroring. It's like a ray of light going through 2 parallel planes. You're going to have the same breakdown, A, C, D, and B. E, G, H, and F. They're going to be exactly the same. Okay, alternate interior angles have the same measures, so basically this is 120, and this is 120, and you get a 120, and you get a 120, and you get a 120, and then this is 60, and you get a 60, and you get a 60, and you get a 60. So there are only 2 real measurements in this whole thing. Okay? So those are interior angles. Now you know what those are. Okay. I'm going to do this one for you, with you. Watch me closely. I know a couple things right off the bat. I know A plus B plus C equals 180, right? And then it's going to tell me that B plus C over A equals 2 over 3. And it's going to ask me, what is B plus C? I don't know what B plus C is. I don't know what B plus C is. What can I do here that will be helpful? Gosh, it would be great to get A, because I'm solving for B plus C. I'm solving for B plus C. I'm going to keep those 2 things together. Well, this equation that I figured out on my own, B plus C equals 180 minus A. Oh, that's nice. Oh, that also means that A equals 180 minus B plus C. That's really interesting. That's more helpful. This thing is more helpful right here, because I want B plus C. I want to get B plus C. B plus C over 180 minus B plus C equals 2 over 3. 3 times B plus C equals, so I'm cross multiplying here, equals 360 minus 2 B plus C. So I'm going to add 2 B plus C plus 2 B plus C. So I'm going to get 5 times B plus C equals 360. Divide by 5, divide by 5. 360 divided by 5 is 72. And that's the answer. So I've done this a couple times. The thing here is you could separate B and C and just solve for A and be doing algebra forever and ever and ever. Or you could just treat B plus C as one boggle, one unit, one apple, and just say, I'm going to keep B plus C together forever, forever, forever. Like high school sweethearts, they just get married and they stay together the whole problem, no matter what. And so when I get, let me clear this out and do this again. So when I got A equals 180 minus B plus C. So I have A plus B plus C. And I subtract B and subtract C. So I have 180 minus B plus C. That's what I started with. And then they tell me that b plus c divided by a, which I just solved for, 180 minus b plus c, equals 2 over 3, and then it begins. And the big thing is I just keep b plus c together the whole time. So it becomes 3 times b plus c equals 360 minus 2 times b plus c. B plus c. And then I add 2 b plus c. 5 b plus c equals 360, and there you go. Okay, questions on how I did it? Whitney, are you good? Good, thumbs up? Okay, awesome. That was tough. That's why I did it. But everything can be done with basic algebra rule, or basic algebra and solid geometry knowledge. Okay, now it's your turn. I'm going to give you a minute and 10 seconds. Go. Okay, let's see how you did. I'm going to open the poll in 3, 2, 1. Go for it. Oh, you need to see the screen. See the screen? Here we go. Oh, man. Okay. 100% of you chose C. That sounds good. All right. A plus B or 180? Well, yeah, you nailed it. You crushed it. A. This is B, B, A, B, B. Excellent, 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 excellent. A plus B is 180. Great job. Great, great job. Booyah. Julie is correctamundo. Excellent job, guys. Let's keep it up. Let's do it. Okay, good. Angles of a triangle. A triangle is a polygon with three sides that has both interior and exterior angles, but it's what's on the interior that counts, along with many properties that accompany them. Interior angles in a triangle are located inside the polygon at each vertex and sum, and they sum up to 180. Okay, so r plus t plus s is 180, and that's what really matters. In the triangle on the right, angles r, s, and t are interior angles, so r plus s plus t equals 180. Cool. Exterior angles, which is what other people judge you on, are formed by one side and a line extended from an adjacent side. So honestly, fortunately, on the GRE and unlike in life, exterior things will be rather rare on the GRE. It will be mostly about interior angles. But you need to know what exterior angles are just in case. So if you have let's say you have an equilateral triangle. What is an exterior angle? Well, an exterior angle is formed by one side and a line extended from an adjacent side. Okay, so in this case, you have one side and a line extended from an adjacent side. Got it. So this exterior angle is 120 because this is the line. Here's another one. This exterior angle is 120, right? Because this is the line and this is 60. This exterior angle is 120. Guess what? Exterior angles add up to be 360 for a triangle. That's how you can check yourself. So, in the triangle on the right, angles x, y, and z are exterior angles. What's the sum of x, y, and z? Type it in the box. What is the sum of x plus y plus z? What is the sum of x plus y plus z there? Silvani has nailed it. Crushed it. Crystal, thank you. It is indeed 360. That's exactly right. That's exactly right. Okay. So let's clear this writing here. Boom, boom. Let's move on. Okay. Angles and sides. Congruent. Congruent triangles are exactly the same. Two triangles with the same side lengths are congruent. They automatically have the same angle measures. Okay. Good to know. Right. 100% that's true. I guess that's, yeah. So if two triangles have the same side lengths, they are the same triangles. Okay, that's what this is saying. Similar triangles have the same angle measurements, but different side lengths. So you can have a 3, 4, 5 triangle or a 30, 40, 50 triangle, right? Those are different triangles, but they have the same angles. Got it. The sum of any two sides is greater than the third side, otherwise the triangle could not be a closed shape. What does that mean? Well, let's check this out. If you have a line, and let's say you have a 7 over here and a 10 over here, can you have the third side of the triangle be 17? You can't, because if you had a side that was 17 long, it would lie flat on this line. Can you have a third side of the triangle be 16? Yes, you can. Because this could connect to this, which would make it, you could have a 16. Cool? So the sum, so the third side has to be less than the sum. The third side has to be less than the sum. So this, or the sum of any two sides is greater than the third side. So the third side is less than the sum. The third side is also greater than the difference. What the heck does that mean? Well, let's say you had the same thing. You had a line here, you split it into 7 and 10, and then you just started folding this over. Started folding this over, this 7, you started folding it over on top of the 10. And then let's say you folded it all the way over. Okay, could you have a third side of this triangle that is exactly 3? No, because then it's lying on top of the line. It's lying on top of the 7 folded all the way over. So let's pick this up again. Let's pick this 7 up off of the floor. And now we have this 10 and 7. So is this side here, is that more than 3? Is this stretched out a little bit? Yeah, it is. So this could be 4. So the third side of any triangle has to be less than the sum of other two sides, but greater than the difference of other two sides. Does that make sense? Does that make sense? Yes? Okay, great. All right. Erase. Boom, boom. All right. If 2 or 3 angles have equal measures, then the sides opposite those angles are of equal length. What the heck? What in the world does that mean? If 2 or 3 angles have equal measures, then the sides opposite are of equal length. So if these are equal, then these are equal, because those are the sides opposite the equal angles. Okay? And if you have equilateral triangle, then all sides are equal. If a right triangle is divided into 2 triangles by a line perpendicular to the hypotenuse, what the heck does that mean? Well, the hypotenuse is the longest side. Is your longest side, and if you do something that's perpendicular to it, then this triangle, the big one, this small one here, and this small one here are similar triangles. Similar triangles, meaning they have the same angles. So here's your right angle here, here's your right angle. Okay? Good deal? That is very unlikely to come up on the GRE, but we cover it because we are comprehensive. All right, guys, go ahead and try this one on your own. 2 minutes, go. Okay, gonna come back and open the poll. Let's see how you did. Let's open the slide. All right, so lock in your answer, figure out what it is. We're gonna open the poll in 3, 2, 1. Once again, here's the screen, and go for it. Oh, so close. Oh, not that close. Okay, we had 100% at A, and then we decided that D was also a really good option. All right, so let's check this out. Two sides of a triangle measure 5 centimeters and 12 centimeters, respectively. Let's do this. Two sides of a triangle measure 5 and 12, respectively. Cool. So it could be this. It could be that, or it could be this. Or it could be this. All right. A, the length of the third side definitely has to be less than 17 and greater than 7. Okay. And B says 6 centimeters. There is no way that the third side can be 6 centimeters. Why? Because if you fold it over that 5 centimeter thing, so if you folded this over, this is 5, and then this is 12. If you folded that over and put it right on top of it, 5, this thing is 7. It's got to be bigger than 7. So A has got to be bigger than B. Guaranteed. All right, why did you choose D, guys? 2 of you chose D. Tell me why. Tell me why. I'm here to help. Nothing? No admission? No admission. All right, guys. We got 30 minutes left. I need you to stay with me so we can finish out math and do a bunch of verbal. And I need to know why you're missing things. So 2 of you missed that. It was a concept that we just went over. So, all right. I didn't use the nice formula of adding and subtracting the 2 numbers. Okay, so the third side is greater than the difference, less than the sum. Okay? Think about the 2 sides of the paper or the thing that I drew. You have a big long line. You divide it at 7 and 10. If you fold the 7 over onto the 10, you get 3, but you can't have 3. It's got to be bigger than 3. It's got to be bigger than the difference. It's got to be less than the sum. Okay. All right. Go ahead and try this one. I will give you 2 minutes. Go ahead. Okay, coming back. Let's see how you did. In 3, 2, 1. And one last look. Go. One more person. Vote. Okay. Almost unanimity on C, which is good. In the figure above, XZ is parallel to WB. If B is 65, B is 60. Hold on. I'm in a lot of trouble here. All right. I'm just going to do it like this. B is 65. What is A plus C? Well, B is 65. Is it too small for you guys? All right, Andrew can't see it. And try to get this going again. Some technical issues. Okay. All right. B is 65. And XC is parallel to WV. So I bet this is 65. So I bet this is 15. And this is 25 because this is triangle here. And this is 25. What is A plus C? Well, C sure looks like 180 minus 25. So 180 minus 25, I think, is 155. So 155 plus 115. That's it. C. Okay. A little more slowly. Or did the one person who missed it, do you have it now? 65. 65. Once you get that, you can solve the rest. If they're similar triangles, they're going to have the same angles. Okay? Any questions? Let's move along. All right, oops. Common right triangles, 2 of the most common right triangles are below. We have these you must memorize. I don't ask you to memorize that much, but you got to memorize this. So this is your 30, 60, 90 triangle. They are in the sides are in the ratio of A root 3, and 2A. Okay? A root 3, and 2A. The smallest side across from 30 is A. The next side, A root 3, is across from 60, and 2A across from the 90 degrees. You have to memorize this because they don't make sense. You can't, you know, the 60 degrees is twice the angle of A, but this side is not at all twice the length of A. This is A times root 3. So this is your 30, 60, 90 triangle. A root 3, 2A. And then here's your other one, your isosceles right triangle, where you have 2 equal sides across from the 45-degree angles, A, and then your hypotenuse is A root 2. Hypotenuse is A root 2. Okay, you must memorize these triangles. You've got to know them. Okay, oops. certain right triangle's shortest side is half the length of its hypotenuse, aha, x 2x. That means this is x root 3. If it's a right triangle and one side is exactly half, you have x, you have 2x, the third side is going to be x root 3. What is the measure of the triangle's smallest angle? 30 degrees. You're done because you memorized that triangle. That is a 15-second problem. Okay? You have to memorize the 30, 60, 90 and the 45, 45, 90. Okay, Pythagorean theorem, a squared plus b squared equals c squared. That's it. The squares of the legs are equal to the squares of the hypotenuse. That's it. Pythagorean triples, these 4 Pythagorean triples are common. Basically, 3 squared plus 4 squared equals 5 squared. 5 squared plus 12 squared equals 13 squared. 7 squared plus 24 squared equals 25 squared. 8 squared plus 15 squared equals 17 squared. Okay? 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. That's it. Most common Pythagorean triples on the test. Okay. Go ahead and do this one. You know what? This one is not good. It's just testing rounding. So we're going to skip this one. Area of a triangle, you must know, it's 1/2 times base times height. The area of any triangle is 1/2 times base times height. That's it. Here's your base. Here's your height. The height is an altitude dropped from the opposing vertex and makes a 90-degree angle right there. Cool? All right, guys. This I would like you to do. So go ahead and take 1.5 minutes and do this. Go. Okay, let's see how you did. We're going to open the poll in 3. Actually, take one last look. Decide what you want. Open the poll in 3, 2, 1. Go. All right. Oh, so close. Okay, check it out. Close. 80% of you got B. 1 of you got D. All right, let's see what happened. Okay, a certain right triangle has side lengths x, y, and z, where x equals y. Cool. It's an isosceles right triangle, x, y, and z. If the area of this triangular region is 8, area equals 1/2. Base times height. Guess what? Here's the base. Here's the height. And they're the same. 1/2 x times x. It's the same thing. 8. 8 equals 1/2 times x squared. 2. 16 equals x squared. X equals 4. That's it. It's B. That's the answer. Okay, for the person who got D, do you understand how it is B? Just nod your head. Nod your head knowingly. Okay. All right. Okay, let's do the rest of geometry here. I think we're going to end by finishing out geometry. All right. Thank you, the person who got that one incorrect. You will go the distance the next time. All right, equilateral, isosceles, and irregular. What qualifies a triangle as a certain type? If all 3 sides are equal, the triangle is equilateral. Each angle is 60 degrees. If exactly 2 sides are equal, the triangle is isosceles. If no side is equal to another, the triangle is irregular or scalene. Scalene. Bad. 2 triangles whose angles are identical, but whose sides are not identical, are called similar triangles, like 3, 4, 5, and 30, 40, 50. Since the triangles have identical angles, the sides of each triangle have the same ratio, they are proportional. In other words, triangles are the same shape, but different sizes. Okay, so let's do this one. I will do this one with you / for you. The perimeter of a right triangle with legs of 6 and 10. Huh. A right triangle with legs of 6 and 10. Huh. 6 squared plus 10 squared equals z squared. So 36 plus 100 equals z squared. 136 equals z squared. Wow. No idea what that is. Almost 12. So root 136. The perimeter of an isosceles triangle with the non-congruent side measuring 10, okay, and a height corresponding to the non-congruent side of length 6. A height corresponding to the non-congruent side of length 6. What the heck does this mean? The perimeter of an isosceles triangle, 2 sides are the same, with the non-congruent side measuring 10, and a height corresponding to the non-congruent side. A height. So, isosceles. All right, so this is 10, and this is x, and this is x, and the height is 6. What is the perimeter? Well, gosh. I have no idea. I wonder if we can figure this out. Hmm. Well, I think it's this. 5 squared plus 6 squared equals c squared. So 25 plus 36 equals c squared. 51, sorry, 61 equals c squared. 61 squared is 61. So I think the 16 plus almost 12 versus 10 plus almost 8 plus almost 8. 16 plus 10, you get 26. This you get 28. And I would probably choose A. But that's brutal, and that's very, 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 very complex. So let's see what your questions are. So questions 8. 2 inner triangles equal. Yes, thank you, Silvani. I think I got that eventually. I thought there was a Pythagorean triangle that is 6, 8, 10. You are correct, Crystal. But this quantity A says the legs are 6 and 10. So the legs are 6 and 10. So you can't say that this is 6 and this is 10. That's not right. It says the legs, the stems, the gams are 6 and 10. So you cannot use that 6, 8, 10 Pythagorean triple. Believe me, it would have been a lot easier. Yeah. That was tough. I think it's A, though. Kind of brutal. All right. Let's wrap this up. Erase. Okay. We did geometry. We have done angles. We have done geometric notation. We've done right triangles of all kinds. We've done equilateral triangles, isosceles, and irregular/scalene triangles. Here are your practice problems. Please do number 9. Number 10 is cool as well, but it's rather easy. And there is your slide filled with takeaways. Recognize vertical, supplementary, interior, and alternate interior angles. Also recognize exterior angles, but don't judge a triangle based on its exterior angles. Practice using a combination of angle properties to solve GRE questions. Correctly interpret geometric notations. Have confidence in using triangles' interior, sometimes exterior angles to answer questions, as well as be able to find a triangle's area. Identify different types of triangles and use their special properties to save time. Okay, that's your homework. We just did a ton of math. Next time, we are going to pick up with verbal. This is what we're going to do. It's going to look like this. Verbal session 7. It's a 25-slide lesson. It's actually about, it starts really on slide 4, and then we have about 10 questions. So we are going to hustle through verbal session 7. We are going to do the writing. We are going to do one little bit more of math, and then I'm going to take about 10 minutes at the end and talk about the psychology of the test. Okay, so that's what we're going to do next time. It is 9:54, and we have a little extra time. So what extra questions do you have right now? So anything we should do ahead of class to actually finish material? Yeah, it would be nice. Writing part 2. Just do the homeworks that I've assigned and keep in touch. And the thing that would help me most is if you guys showed up to office hours. So office hours, crack it on tomorrow, 7:45 a.m. If you can get up and come, it would be awesome. If you can't come, send your questions by email, and I can answer them over email. I do want to say just a couple things about the psychology of the test. The GRE, much like grad school itself, is a test of will. It is a test of stamina. It is a test of poise. You are alone, and the only thing that can prevent you from doing what you want to do is the same thing. Is the one and only tool you have to help you. So your own thoughts are both propelling you towards grad school and keeping you from grad school in the form of distracting you from the correct answer on this test. So on the GRE and during grad school itself, you are going to have negative thoughts, and that just happens. They come into your brain, and that is just human nature. Now, my girlfriend thinks that I should not have negative thoughts, especially about her or our relationship, but sometimes they happen. And the choice then is what you do with those negative thoughts. So, for instance, on the GRE, or in the case of my relationship, if I want to stay in the relationship, I say, thank you for coming, negative thought. I would politely ask you to leave. Thank you, please come back after I am done with this test. Or in the case of my relationship, never, please never come back, because I would like to stay with her. Thank you. You have to tell yourself when you're on the test that you are in control of what you think. Because if you get distracted, if you start thinking about, oh my gosh, I'm really learning a lot about amoeba, oh my gosh, this is such an interesting reading passage, I never knew that about climate change, you can do whatever you want. But your goal, your only objective, is to finish the test, finish every question on it, and get the right answers. One question after the other. Minute and a half, minute and a half, minute and a half. It's a timed test. And if you start having thoughts about how hard the question is, whether you got the last one right, I wonder what it'll be like the first day I'm at Harvard, those are unhelpful. They're not helping you get the question in front of you. Your job is to prepare for the absolute worst physical scenario that could happen. The person next to you has Ebola. The proctor is your ex-boyfriend. The person who you passed on the subway was your soulmate, but you can't meet him right now because you're on your way to the test. All these things. Just expect them to happen. I actually had I had someone not throw up on me, but spill an unknown and very, very odoriferous blue beverage on me on the subway on the way to one of my GMATs. And I still had to take the test. Soaking, sticky, gross. I've gotten lost on the way to the test. I'd fallen asleep during a reading passage and lost 11 minutes on a reading passage that actually happened. On my GRE, someone's cell phone went off, and I had 1 minute left on the math section and 2 questions to go, and it would not stop ringing. And he couldn't pick it up, because if he picked it up, he'd be admitting that he brought a cell phone in, so he just abandoned his cell phone. It was bad, but I finished those 2 questions, and I got a 99th percentile and went to Harvard, and that was it. You choose how poised you are. You choose how focused you are. You choose what to do with the thoughts that come into your head, and you choose what to do with the distractions that pop up. So we'll talk a little bit more about the psychology of the test and what it's like to approach the test and what to do on test day. But for now, I wish you a very good night. Thank you for coming to Lesson 7. I can't wait to finish the course with you on Thursday night, Lesson 8. And I will see you guys tomorrow morning at office hours. Good night, everybody.